Okay, so you should have a foldable that looks similar to this at this point. On the inside, you have two spaces for inorganic and organic, and then you wrote the phrase "no cats on hot plates" at the bottom. This is the foldable that you're going to take your notes in as you go through these next few slides in the next few minutes. So again, inorganic and organic is what we're talking about. And the question that we're asking is, how can you tell if a compound is organic or inorganic? And the phrase that we use that you've already written down is "no cats on hot plates." And that will help you, and you'll see in a second, remember which elements that you can find on the periodic table, which of those elements make a compound organic or inorganic. So go ahead and open up your foldable, and we're going to be working in those first two columns that say organic and inorganic. So you can see we have the definitions here of what's considered organic and what's considered inorganic. So the first one for inorganic says it does not have a carbon-hydrogen bond. And if you see on the organic side, it said it does have a carbon-hydrogen bond. So the main difference in what makes something organic and inorganic is that carbon and hydrogen. They have to be bonded together in the compound for something to be organic. And organic means that it is made of or by living things. You can see that in your notes as well. So if it's organic, it's got a carbon-hydrogen bond and it's made of or by living things, whereas inorganic compounds do not have that bond and they are not made of or by living things. And we are going to write some examples down there, so leave a little bit of space at the bottom for some of those examples. Now, one of the exceptions, or one of the things that we have to talk about, are that there are exceptions to a compound being organic and not having a carbon-hydrogen bond. For 8th grade chemistry, we're not concerned with those exceptions, but you do need to know that there are some. So as a general rule, though, a carbon-hydrogen bond is what makes it organic. On your foldable, you have, on the outside, you have the flaps that are marked with element symbols. And so each of these elements symbolizes something. So for the next two slides, you're going to use the information and you're going to write the name of the element. So on the outside, this first one is an N, and if you look on your notes, it says nitrogen. So you're going to write nitrogen underneath it. And then you're going to put all of the information that you see there, the atomic number, atomic mass, group number, period, and the number of valence electrons on the inside of that flap. So for each of the elements that are considered are considered organic, you're going to put that on the outside. Now while you're doing that, I want to point out that our phrase, "no cats on hot plates," each one of those bolded letters, the first capital letter of each word, and then the very last S, represents one of the elements that is considered organic. So our "no," we have N, and that stands for nitrogen. The C stands for carbon. The O stands for oxygen. The H is for hydrogen. The P is for phosphorus, and the S is for sulfur. So continue to put this information on the back of each of the flaps. You can pause the video if you need to in order to get that information down, and then continue when you're ready. Okay, here we're going to do some examples. So on the inorganic and organic columns on the inside, we'll talk about which of these elements is organic and inorganic. So first, we have C12H22O11. That is organic. That is organic. So write that in the organic column. The next one is H2O. Do you think it's organic or do you think it's inorganic? If you said inorganic, you would be correct. Even though hydrogen and oxygen are considered organic elements, the compound doesn't contain carbon, and so the compound is inorganic. NaCl, this is your table salt, sodium chloride. If you said that this one is inorganic, you would be correct. Sodium chloride is inorganic. C6H12O6. This should be a familiar compound. You use this one in photosynthesis, and if you don't remember, this is glucose. So is glucose organic or inorganic? The correct answer is organic. Organic. So make sure you write that under the organic column. Now you have CH4. CH4. C is carbon, H is hydrogen. So this compound would be organic. CaCl2. This is calcium chloride. There is no carbon and no hydrogen anywhere in the compound, so the compound is considered inorganic. C8H18. C8H18. This compound is organic. Organic. C2H5 and then OH. This compound, even though it's written differently, it's written in molecular form, this is considered organic because you can see that the carbons are bonded to the hydrogens directly. We do have an oxygen-hydrogen bond, but our carbons are bonded to our hydrogens, so this is an organic compound. Now we have a different molecule with multiple compounds in it. We have actually 2 carbon-hydrogen bonds in this compound. So our first one is the center C with the H below it. And then above the center C, you actually have a carbon-hydrogen 3 bond. So this compound is considered organic. CO2. CO2. This is considered inorganic. Even though carbon and oxygen are both organic elements, there's no hydrogen bond anywhere in CO2, so it is an inorganic compound. Now C60. C60 is considered inorganic because it is only carbon. There's no carbon-hydrogen bond anywhere in it. That is all for your foldable, so make sure you glue it into your notebook on the page for 7-6A. It goes on 7-6A, and you'll take the back and you'll put glue on it, you'll glue it down in there, and then any extra notes that you need to take, or if you needed extra space for your examples, you can do that on that page as well. But if you need to go back and watch the video again or parts of the video, then feel free to rewind it and do that again. All right, that's it.